Join me as I dive into some crazy electrical myths and see if I can bust them all wide open. Electrical myths are all around us, and they can be downright dangerous. We've all heard them, the old wives' tales and misconceptions that get passed around, often causing more harm than good. Understanding the facts about electricity is crucial, not just for safety, but also for our own peace of mind. Electricity is something we use every day, but often take for granted. We flip a switch and voila, the lights come on. But have you ever stopped to think about how it all works? Probably not, and that's exactly why myths and misconceptions spread like wildfire. These myths aren't just harmless misconceptions, they can lead to serious safety risks. Imagine thinking it's okay to do something around electricity because you've heard it's safe, only to find out it's not. That's why it's so important to separate fact from fiction. By understanding the truth about electricity, you can protect yourself and your loved ones from potential dangers. So, how do these myths start? Sometimes it's just a misunderstanding. Other times it's a half-remembered piece of advice from someone who's not an expert. Whatever the reason, it's up to us to set the record straight. Let's talk about some common electrical myths. First off, there's the idea that you can get a 240-volt shock from a single outlet. This one's been around for ages, but it's simply not true. You might get a shock from an outlet, but it won't be 240 volts if you're in a standard single-phase residential setup. Another myth is that it's safe to touch electrical wires as long as you're not plugged in. The truth is, wires carry voltage even when there's no load on them. That's why electricians always treat wires with caution, regardless of whether they're live or supposedly dead. Then there's the claim that using a GFCI outlet can protect you from all electrical shocks. While GFCIs are incredibly important for safety, especially in areas like bathrooms and kitchens, they don't cover every possible electrical hazard. They primarily protect against ground faults, not all types of electrical shocks. Some people also believe that if you use energy-efficient bulbs, you can have more lights on at once without worrying about overloading the circuit. This one's partially true, but also partially false. Energy-efficient bulbs do use less power, but your circuit's capacity is still limited. You can still overload a circuit with too many of them. There is one myth, however, that I find particularly surprising. Many people don't know that you shouldn't use a 3-prong plug with only 2 wires. It seems harmless, but that third prong is there for a reason. It's the ground wire, designed to protect you from electrical shocks. If you only have 2 wires, you're essentially bypassing that safety feature.
The reason this myth is so surprising is that it's often considered an upgrade or a quick fix to save some money. But think about it. Without that ground wire, you're putting yourself and your devices at risk. It's just not worth it. Recapping the main myths we've discussed, from the 240-volt shock to the 3-prong plug, it's clear that electrical safety isn't something to take lightly. These myths might seem harmless, but they can have serious implications. If you've ever fallen for one of these electrical myths or have a story about a close call with electricity, I want to hear about it. Share your experiences in the comments below. Don't forget to like, share, and subscribe for more videos where we dive into the fascinating world of science and technology. Myth 1. Electricity takes the shortest path to ground. People often say electricity takes the shortest path to ground. That's not true. It actually takes all available paths based on resistance. Show diagram. 1 short wire, 1 long wire, both getting current. Multimeter showing parallel paths drawing current. Electricity follows all conductive paths. Lower resistance paths carry more current, not just shorter ones. Myth 2. Rubber shoes protect you from electric shock. Wearing rubber-soled shoes might give you some insulation, but they don't guarantee protection. Most rubber in shoes isn't rated as electrical insulation. Person wearing sneakers touching live wire-controlled setup. Real safety boots labeled Class 0. Class to Myth 3. Birds don't get shocked because they're light. It's not about the bird's weight. It's about the fact they touch only 1 wire. No voltage difference means no current flows through them. Bird on 1 wire versus touching the wires or a wire plus pole. Animation of current path in different scenarios. Myth 4. A device that's off can't shock you. Wrong. Devices still connected to power can carry voltage inside. Even when off, internal capacitors or residual energy can still cause shock. Multimeter showing voltage on off device. Example, microwave, TV, power supply. Myth 5, voltage kills. Not current actually, it's current that kills. Voltage only provides the pressure to push current through your body. Just 100 milliamps can be fatal. Diagram, voltage versus current. Comparison, taser voltage versus electric shock current. Myth 6, low voltage is always safe. Even 12 volts or 24-volt systems can be dangerous under the right conditions, especially if the skin is wet or if there's high current involved. Battery terminals and dry versus what skin tests. Label showing current flow with Ohm's law. Myth 7, grounding prevents all shocks. Grounding helps redirect fault current, but it doesn't stop all shocks. If you're part of the circuit, current can still flow through you to ground. Safe grounding versus shock through body. Myth 8, circuit breakers protect people from shock. MCBs or fuses are designed to protect equipment, not people. They trip on overload or short circuits, not small leakage currents that can kill. That's what RCDs or RCCBs are for. MCB versus RCCB side by side. Current thresholds labeled. Myth 9, you can test wires just by touching or feeling them. This one's extremely dangerous. Never rely on feeling if a wire is live. Always use proper testing tools. Comparison, taser voltage versus electric shock current. Myth 6, low voltage is always safe. Even 12 volts or 24-volt systems can be dangerous under the right conditions, especially if the skin is wet or if there's high current involved. Battery terminals and dry versus what skin tests. Label showing current flow with Ohm's law. Myth 7, grounding prevents all shocks. Grounding helps redirect fault current, but it doesn't stop all shocks. If you're part of the circuit, current can still flow through you to ground. Diagram, person touching energized appliance. Safe grounding versus shock through body. Myth 8, circuit breakers protect people from shock. MCBs or fuses are designed to protect equipment, not people. They trip on overload or short circuits, not small leakage currents that can kill. That's what RCDs or RCCBs are for. MCB versus RCCB side by side. Current thresholds labeled. Myth 9, you can test wires just by touching or feeling them. This one's extremely dangerous. Never rely on feeling if a wire is live. Always use proper testing tools. Show non-contact voltage tester multimeter. Seen with electrician testing safely versus unsafe tap test. Myth 10, electricity can't travel through water. Pure water may be an insulator, but tap water is full of ions and conducts electricity very well. That's why wet conditions are so hazardous. Beaker with distilled versus tap water test. Electrocution danger sign in bathrooms, kitchens and YTHS. Rapid fire round. Myth 11, aluminum wiring is illegal. Not always. It just needs special care. Myth 12, thicker wire is always better, only if it matches system design. Myth 13, neutral wire has no voltage. Wrong. It can carry return current and shock you. Myth 14, only professionals get electrocuted. Dyers are even more at risk. Myth 15, turning off a switch cuts all power, only if the switch is on the live line. Bad wiring can leave voltage behind. Show quick flash scenes of each myth with or B-roll of real-life applications. Myth 17, you don't need to turn off the main breaker to change a bulb. Truth, while many people casually change light bulbs without switching off the circuit, this is risky. If the switch or wiring is faulty, the socket may still be live. Reality, always turn off the circuit or at least ensure the switch is reliable and off. It's a low-risk job until it's not. Show someone changing a bulb with a faulty switch. Spark flashes. Proper method. Turn off breaker gives change, bulb gives turn back on. Myth 18, all black wires are always live in white or neutral. Truth, color coding is standard, but only when wiring is done correctly. In older or DIY wiring, color conventions are often ignored. Reality, always test wires before working on them. Never rely on color alone. Diagram of correct color codes versus messy, mixed up DIY wiring. Voltage tester confirming unexpected live white wire. Myth 19, if it doesn't spark, it's not dangerous. Truth, electricity doesn't always give a warning. A deadly shock can occur silently, especially with DC current or through poor insulation. Reality, many fatal shocks happen without a single spark. Don't wait for a flash. Stay cautious always. Side by side, dramatic spark versus quiet electrocution simulation. Safety sign, no spark does not equal no danger. MYTH 20, you can fix all electrical problems with electrical tape. Truth, electrical tape is for temporary insulation or identification, not permanent wire joins or exposed connections. Reality, improper use of tape leads to loose connections, heat buildup, and fires. Use proper terminals, connectors, and enclosures. Messy tape wires overheating. Contrast, proper wire nuts, junction boxes. Secure terminals so now you know don't believe everything you hear about electricity. Myths can be dangerous, and knowing the truth might just save a life. If you learned something new today, hit that like button, subscribe, and share this video. Stay safe and stay charged. Subscribe. Hit the bell. Stay shock-free.